The brain. Your brain never sleeps, not even for a second. Right now it's processing this video, monitoring your breathing, regulating your heartbeat, and storing memories, all simultaneously, without you doing anything. 86 billion neurons, each connected to thousands of others, firing constantly at speeds of up to 120 meters per second. If you counted one neuron per second, it would take you 2,700 years to count them all. And here's what makes it genuinely strange. Your brain feels no pain. It has zero pain receptors. Brain surgery can be performed on a conscious, talking patient, because the brain itself cannot feel the scalpel touching it. It also rewires itself constantly. Every time you learn something new, physical connections between neurons change. Every habit you build, every skill you practice, every memory you form, literally reshapes the structure of your brain. Scientists call this neuroplasticity, and it means your brain today is physically different from the brain you had 5 years ago. Despite being only 2% of your body weight, it consumes 20% of all your energy, the most expensive organ you own, and the one you understand the least. The heart. Your heart will beat over 2.5 billion times in your lifetime. Not once will it ask for a break. 100,000 beats per day, pushing blood through 60,000 miles of blood vessels, enough to wrap around the earth twice, every single day. The left side pumps oxygen-rich blood to every cell in your body. The right side collects it back, now oxygen depleted, and sends it to your lungs to reload. This cycle completes itself roughly once every minute. Here's something most people never think about. Your heart has its own electrical system. It generates its own impulses independently of your brain. That's why a heart can keep beating outside the body when kept in the right conditions. It doesn't need your brain to tell it what to do. That electrical signal is what doctors read on an ECG. Every spike on that graph is one contraction, one beat, one cycle of life support delivered to every cell you have. The lungs. 20,000 breaths today. You'll remember none of them. Inside your lungs are millions of tiny air sacs called alveoli, clustered like bunches of grapes, with walls so thin that oxygen passes directly through them into your bloodstream in milliseconds. At the same time, carbon dioxide passes back out, the waste product of every cell in your body, expelled with every exhale. If you flattened every alveolus in both lungs and spread them out flat, the total surface area would cover a tennis court. All of that, folded inside your chest. Together, your lungs process about 2,000 gallons of air every single day. And they do it in two slightly different sizes. Your left lung has 2 lobes, your right has 3. The left is smaller, making room for your heart sitting slightly left of center. Your body literally redesigned itself around its own priorities. One more thing, your lungs are the only organs that float. Remove them and place them in water. They float. Every other organ sinks. The liver, 500 functions. 1 organ. No other organ in your body comes close to that number. Not even your brain. Your liver filters every drop of blood that leaves your digestive system before it reaches the rest of your body. It neutralizes toxins, breaks down alcohol, processes medications, and removes bacteria from your bloodstream, constantly, without pause. At the same time, it produces bile for digesting fats, stores vitamins and minerals, manufactures proteins needed for blood clotting, converts excess glucose into glycogen for stored energy, and breaks down old red blood cells. All of this, simultaneously, 24 hours a day. But here's what genuinely surprises most people. Remove 75% of your liver, surgically in a living person, and the remaining 25% will grow back to full size within weeks. It is the only internal organ capable of complete regeneration. Surgeons use this fact to perform living donor liver transplants. A healthy person donates part of their liver, the recipient's new portion grows, and the donor's portion grows back. 2 people leave the hospital with full livers from 1. The kidneys. 200 quarts of blood filtered every single day. That's your entire blood supply cycling through your kidneys roughly 40 times daily. Every drop of blood you have passes through them repeatedly, getting cleaned, balanced, and returned. They remove waste products, regulate levels of salt, potassium, and calcium in your blood, control blood pressure by releasing specific hormones, stimulate red blood cell production, and keep your bones healthy by activating vitamin D. All of that from two organs the size of a computer mouse. Here's the part that puts their design in perspective. You only need one to survive. People donate a kidney to a stranger and live completely normal, full-length lives. The remaining kidney detects the absence of its partner and simply expands its capacity to handle the full workload alone. No recalibration required, no recovery period for function. It just adapts. Your body built redundancy into one of its most critical systems. It gave you a spare, and made sure that spare was fully capable of running the whole operation by itself. The stomach. Your stomach produces acid strong enough to dissolve metal. Hydrochloric acid, the same category of corrosive acid used in industrial cleaning and manufacturing, is what your stomach uses to break down food. The pH inside your stomach, when fully active, sits between 1.5 and 3.5. Battery acid sits at 1. The only thing stopping your stomach from digesting itself is a thick layer of mucus lining its walls. Your body replaces this mucus constantly. When it fails, when the lining breaks down faster than it can be replaced, you get an ulcer. Your stomach can stretch to hold up to 4 liters of food and liquid, roughly the size of a small watermelon when full. Empty, it's about the size of your fist. After 2 to 6 hours of churning and mixing with acid and enzymes, it releases everything into your small intestine in controlled bursts. A valve called the pyloric sphincter, deciding exactly when and how much passes through. A self-cleaning, self-protecting, industrial-grade processing unit, sitting quietly in your abdomen. The intestines. Your small intestine is 20 feet long. Coiled inside your abdomen, it doesn't look small. It's just narrower than the large intestine. And what happens inside it is where the real work of digestion occurs. Its inner walls are covered with millions of tiny finger-like projections called villi. Each villus is covered with even smaller projections called microvilli. Together they create a surface area of roughly 2,700 square feet, the size of a doubles tennis court, packed inside your abdomen. That surface area exists for one reason: absorption. About 90% of every nutrient you consume is absorbed here. Every gram of protein, fat, and carbohydrate that fuels your brain, muscles, and organs enters your bloodstream through those villi. Then comes the large intestine, shorter but wider, about 5 feet long. It absorbs water, compacts waste, and houses something remarkable. Roughly 38 trillion bacteria, not invaders, permanent residents. They produce vitamins, train your immune system, protect against harmful bacteria, and communicate directly with your brain through the vagus nerve, a connection scientists now call the gut-brain axis. What you eat changes your gut bacteria. Your gut bacteria change how you think, feel, and respond to stress. The connection runs both ways. The pancreas. Your pancreas controls one of the most important balances in your entire body. Blood sugar, hidden behind your stomach. This 6-inch organ works like a biological control center. Every time you eat, your pancreas releases digestive enzymes into the small intestine, breaking down proteins, fats, and carbohydrates into particles small enough to absorb. But digestion is only half its job. The pancreas also functions as part of your endocrine system, releasing hormones directly into your bloodstream. The two most important are insulin and glucagon, chemical opposites constantly balancing your blood sugar levels. When glucose rises after eating, insulin tells your cells to absorb it for energy. When glucose drops too low, glucagon tells your liver to release stored sugar back into the blood. Without that balance, the entire system begins to fail. And here's what makes it dangerous. Damage to the pancreas often happens silently. By the time symptoms appear, blood sugar control may already be severely disrupted. A small organ, one of the most fragile control systems in your body.